Okay. Hello everyone. Welcome. Welcome. Good evening. So thank you so much for joining in for everyone. And we are starting now. So let's start with our session. Getting started with cloud. I will start with the session agenda. So what we will be covering today. We have a special guest. He will be telling us about what is cloud. We have a quick introduction to quick labs. Then we will be having hands-on experience with the quick labs in today's session, and then we will introduce you to 30 days of Google Cloud program and what it is and what it has to offer you guys and how can you all take advantage of it. Next up, we have some guidelines, some guidances, from which you can take help from Google for any issues that you might face during the challenge. And then we have our at last giveaways announcement for which most of you are super excited. So welcoming our speaker Slick here. Slick is a Slick is a software engineer and tech community manager with over 6 years of experience. He's a founder of Codenovation, a unified technology-driven platform dedicated to closing the technology talent gap in Africa. And he has created many platforms where community can learn, share, connect, and help access and have access to all the resources and tools needed. So he's also currently building communities with Google GDGs, JetBrains, Kotlin, and Codenovation. So welcoming our speaker Slick. Welcome Slick, and we are super excited to have you and with the for the talk today. And I hope everyone, including me, learns awesome. So welcome and over to you.
Hi, Himandri. Thank you. Thank you for the wonderful introduction. And I'm really excited to be here today as well to start the section. And for everywhere you're watching me, I'm really super excited to actually have this amazing section with you. And hopefully it's going to be amazing and we're going to learn a lot together as well. So I will just go ahead and share my screen. Okay. Okay. Hi, everyone. I'm really super excited once again to have this time with everyone. And we're actually going to talk about cloud computing and Google Cloud Platform, fundamentals and core infrastructure. So this section is actually going to be an interesting one. And I want us to really feel free to drop comments on the chat box. Feel free to drop your questions, your thoughts, why the section is going on, or feel free to actually tweet about the section as well and following the organizers' hashtags as well too. So we're really super excited to do this, and we are really excited to actually get started as well too. So we're actually going to talk about a switch into Google Cloud Platform as well too, which we know that it's actually an amazing platform for cloud computing and its infrastructure as well too. So that's the first thing, and let me introduce myself before we get started. So this is me. My name is Slick Shola Akinrele, a software engineer from Nigeria. Been in software engineer for 6 years, just like Imandre said, and as a community manager as well, I'm building communities with Google JetBrains and Codenovation as well. Then also had experiences with Angular learning community as well too. So as a serial entrepreneur too, actually very interested, not just in tech alone, but at the same time do a lot of things around a lot of things around entrepreneurship as well too. So I would not like to go into the details to that. So today, what are we talking about today? So we're actually going to know a breakdown of what the heck is cloud. I mean, we have to understand cloud to get started. We really need to understand how cloud computing works, forms of cloud computing, Google Cloud Platform, core infrastructures, lab demo, and the future as well too. So it's actually going to be exciting one today. So I hope you're all set and we get started and get prepared for the section. So for the first thing, there is no cloud. It's just someone else's computer. Yes, this mindset is actually really, really wrong. I used to tell people, a lot of people think, oh, there's no cloud. It's just someone else's computer. So I don't think that's really not true. Cloud computing is far beyond just someone else's computer, and we have to understand that we having the impression of there is no cloud is not actually true. It goes beyond. Yes, you can actually logically, or maybe in another thinking, you could actually think, oh, it's someone else's computer you're having access to, and you're using someone else's infrastructure. Yes, indirectly, but far goes beyond the computing power, the energy, the server rooms, and so many other things you have to consider to know that cloud goes beyond that. So at the same time, we are actually going to talk about what the hell is cloud and how do we get to cloud. This reminded me when I was really young. I actually felt cloud. It's something like it's everybody's thinking when we're actually coming up. We always think cloud is something like when we're growing up, we see, oh, there's one thing, there's a cloud on the cloud itself. Maybe probably you have a computer in the cloud and something. It could be really, really funny, but trust me, it far goes beyond that. So there's no cloud in the cloud. The cloud have a physical infrastructure situated and it's actually in the data center. And that's what we're actually going to talk about today, actually. So as a student, you might actually think about cloud, and you might actually think, oh, cloud is just something you do on your computer. Maybe you upload your drive, you actually upload your pictures to the cloud, maybe using iCloud or Google Photos and all that. So for a student, if they ask them what is cloud, you will just think, oh, cloud is just your ability to save your files or back up your files in the cloud and getting started with it probably. And for an IT pro, it will actually tell you that file is actually cloud is actually something you had to do when you talk about building infrastructures and having scalable applications to be hosted in the cloud as well. And a software developer will tell you, well, I don't really know much about cloud. All I know is that I develop application and I ship it in the cloud platform and everything is working. My application works perfectly. The cloud infrastructure do the maintenance themselves and I'm good to go. So as CIO at the same time too. So the state of cloud, but we just be straightforward. The state of cloud, we have to say one way or the other, you have been interacting with cloud, which you don't really know. So it's actually, it can really be funny sometimes that we know that we are actually interacting with cloud and we are not even aware of that. So it's actually something we have to understand and we have to focus on. That cloud computing goes beyond we just start interacting with our phone or our devices, and one way or the other, maybe through Gmail, through Microsoft E365, through other amazing stuff platforms that we actually interact with. We have one way or the other, we have actually interacted with cloud, which we don't really know. So straightforwardly, we just say on-demand computing resources delivered to you over the internet. That's what the state of cloud is. Every day we actually access a Gmail, we have a file stored there, we are interacting with cloud. We are uploading photos on Google Cloud, we are interacting with cloud. We are even accessing Google Search, we are interacting with cloud. We are watching for Netflix guys that does a lot of things around Netflix. You're actually interacting with cloud too. So these are computing resources that are actually delivered to you over the internet. So at the same time, you can actually say it's created traditionally on all local premises. That's another definition of cloud. You have Google infrastructure in the data centers. That is their local premises, on premises. They created amazing infrastructures that employ amazing service and data centers with a lot of virtual machines being created and home premises locally, and now it's being transferred or performed remotely across the internet to you. So you can actually have it. So later on, I'm actually going to talk about operating system as a service, which is like you actually having all your operating system on the cloud, and you are just there accessing it. You don't have to bother about how the Microsoft, the Microsoft OS is installed, or Linux OS is installed. All you just need to do, you put your file on the cloud and you get it started. So from local premises, that is your on premises, to off premises. So cloud all around us. We have to understand cloud all around us. So each day we interact with either Siri or whatever Google Assistant or whatever platform assistant we do uses. Virtual assistants are actually another form of cloud computing sources. So if you're familiar around cloud computing, around Google Assistant, you'll be using Google Assistant or interacting with it. If you're interacting with it, then you have been interacting with cloud. And if you have been building platforms around Google platform, then you have been doing cloud computing as well too. So we have cashless payments, we have cloud computing itself, and we have IoT with machine learning, cloud computing, which makes it amazing. Our data is understanding machine learning, AI around us. So cloud is always around us. So another thing we should actually be vigilant when we're doing cloud is the security aspect. So in the security aspect, we talk about cloud. We have to trust the cloud provider we are actually working with, talking about the downtown, talking about the availability, that's the downtown, and the uptown, looking about the 99 point something percent, might not be 100% downtown, maybe a few seconds. So you have to be sure of your hosting platform secure. Then you have to be sure of a potential data loss to know you actually sure you have to back up your data when you're actually interacting with cloud. So obviously, so that you won't have a data loss or damages. Then you have to be sure that you have fast access to avoid slow access to data. The speed is an important thing you have to consider when working with cloud infrastructures. So like Google Cloud, Amazon, and etc., Microsoft Azure, and etc. So it's actually things you have to understand around cloud. So then you have to make sure you check their legal, regulatory. It's actually very important too to know how your data are being saved, your data, when you build a app, your credit cards, and so many other things you have to understand to know. So then potential for unknown cost, actually you have to be sure of what your cost is, or the infrastructure. This is one of those things we're actually going to talk about too. If you want to set a maximum gauge of how much you want to spend at the time, you want it to scale up, scale down for you when you're building your apps on the cloud. It's actually very important. You have to check those things as well too. So cloud infrastructures, application in life as a service, like I will say that because we have in these cloud infrastructures, a part of infrastructure comes out from this cloud. We have private clouds, and private clouds, they're basically things you do. On premises local servers or local data centers you made around your environment. It could be your organization. You could make a one in your home. If you have something you're powering, you could do it around your environment. But they are on premises cloud infrastructures within your premises. You just want to build a data center or a servers that have virtual machines in your house, and you don't want outside anybody to have access to it apart from you, your data. You just want to keep it to yourself. So that's what we call private cloud. So private cloud exists, and it's on-premises cloud infrastructures around your premises. It could be your home, it could be your organizations, but they only have access to those data, and you're not allowing every other person to have access to it. Why public cloud? Public cloud is actually examples like Microsoft Azure or Google Cloud Platform. Those are things that you actually have access to via the off-premises, via the internet. So their on-premises demand over the internet. So you actually create your data on the cloud, or build it on your Google Cloud Platform. And when you build it on Google Cloud Platform, you can have access to them wherever you are. So Google they have the local data to themselves. Your data to themselves, well secured, under your control. You only have access to them when you needed them. You can build on their platform. You can do a lot of things. So public cloud exists and private clouds exist as well too. So, but now we're going to focus on hybrid cloud. So hybrid cloud does not exist. So what I mean by hybrid cloud does not exist is that a lot of people think there's a physical location for hybrid cloud. No, private cloud has a physical location within your premises. It's more secure. You have access to your data, only you, and you have to understand that that's what private cloud is. While public clouds are off-premises data centers or cloud infrastructures like Google Cloud or Microsoft Azure, and you could actually have access to them where they are located. The data is secured as well. You have access to them over the internet. You can scale up, scale down, whatever you want to do on it. While an hybrid cloud is basically for the combination of private clouds and public cloud. So the combination of private cloud and public cloud give birth to hybrid cloud. So hybrid cloud does not exist. So for example, I'm building an app and I want to have my local my data to actually be offline. I mean to be on my data only, to have actually my database to actually be a private cloud where I have access to all my data only. I don't want Google Cloud Platform to have access to my data. I don't want Microsoft Azure or Amazon to have access to my data. I want to just be secure to myself. So I put my database in my private cloud, which within my premises. I build infrastructure within my premises, or you working for organizations or a company. So you build it within your premises and you only have access to you or all your organization have access to it. Google doesn't have access to you, but you want to put on the web application to run on public cloud. So you can do that as well too. So if you feel your application is heavy and you want to push it to public cloud so that it can be fast, at the same time, interaction between your amazing private clouds infrastructure you built in combination with Google Cloud Platform. So you want to combine them together, actually bring up amazing thing. So then you could connect your public cloud to your private cloud, which forms hybrid cloud. So you connect your database, which you built on your private cloud within your premises, and to your web application or your mobile application, which you hosted on the public cloud, which is the Google Cloud Platform. And you connected together to give you a result of hybrid cloud. It's actually amazing to see that it can be more complex. That's one of the downside, but the upside is more advantages, is more better than the disadvantages. So on this note, you could actually understand that hybrid cloud is amazing because you've shared your services and none of them is being loaded on each other. And at the same time, you spend less when you're having off premises, your part of the application off premises, but it can be more costly, more cost effective for private clouds only if you're using it than to because you have to pay for your infrastructure, build your servers, your data center and everything, your virtual machines, everything gets set. Configuration, maybe probably get the DevOps to manage it for you. I mean, IT ops to manage it for you and all that. So private clouds might be more expensive, but the combination of private clouds and public cloud give you an hybrid cloud. So we're moving on to forms of cloud computing. So we have SaaS. Yeah, so SaaS is actually a software as a service, and it's something that has been going on for a while, and you have been using it, and sometimes you don't even know. So software as a service is one of the most popular cloud platform everywhere, like you should use. So and you have been interacting with it for long, and since talking about from the onset of when cloud started, and how development of history of cloud computing and all that, you would have seen that it's actually something that have been growing over the time, and you understanding how perfectly you can use your cloud computing. So it's actually amazing for you to know that software as a service, examples like a Gmail, Office, 360, Dropbox, etc. So there are so many. So as a service, those are just demand service you actually required that's been delivered to you over the internet. So you interact with these things, and this are software as a service. So to platform as a service, Platform as a service is another platform similar to infrastructure as a service, but in this, the third, a second party providers, that's the cloud providers, they actually provide you with core infrastructures to host your web servers, your simple services, or your platform or your database. You just want to push it on that. You don't want to care how to set up virtual machines, how to do on the configuration. You just want to get your app running on the cloud. Then you are good to go with the platform as a service. Note this, we are actually going to focus more on this, and I'm actually going to give you, when we go into Google Cloud Platform, I'm actually going to difference between when we're referring to platform as a service at the same time to actually understand. So for infrastructure as a service, major infrastructure as a service Amazon provides it, Google Cloud Platform provides it as well too, which is what we are focusing on this section. So in infrastructure as a service, this is a platform where you actually have to provide, you're being provided with virtual machines. So let me explain what I mean by virtual machines now. So virtual machines are basically infrastructures that you have been using for a while, and you are trying to focus on what you actually want to do. So it's just like you having a computer. Virtual machines are just like emulation of a computer system. So imagine you having a computer. You're having a computer and you actually don't know where it's been situated. So you have a computer and you're trying to know where you're hosting it, you're putting it in the cloud. You don't know where it's computer, just like an operating system you have online, and you hosted it online. It's going to have everything the normal operating system has. So like physical infrastructure, like your RAM, your storage, your network, everything, VPU, storage, memory, RAM size, whatever you have, whatever you want to provide, you actually have it. So virtual machines basically are emulation of computer systems, and they are based on architectures and provide functionality of physical computers for you. So they provide the same functionality of a physical computer, like your laptop you have on your physical, on your own premises. You have your laptop, and your laptop is being provided for you. You could access the storage, you could access the RAM size, you could see whatever, you could put an operating system on it, depending on Linux or Windows, depending on operating system, whatever operating system you want to put on it. So why in virtual machines you don't have access to them? Infrastructures, Google Cloud Platform provide with it is a physical location located in the data center. So there are a lot of data centers everywhere. So and that takes me to one of my slides where I show the data centers, and I think my screen time will actually show you again. So these special machines are there configured, and you could have access to them, and you could do your operating system. You could do your configuration there, and you could do whatever things you want to do. You could do it there as well too. So this is actually amazing because Google Cloud Platform had more better infrastructure, and they have more resources and professionals to anchor all those things for you. So all you just need to do is just to create your virtual machine, pay for what you want to use, and you do your configuration. And it has a VPU, storage, memory, and it's all. So basically, that's what you're actually going to do on that. So as we're moving on as well too. So PaaS and HaaS. So let's talk about PaaS and HaaS. So a platform as a service runs on IaaS servers as well. So when the storage are provided for them as well at the same time, because platform as a service runs under infrastructure as a service, because they are the one that provided the storage, the services, the servers, and everything for that, because they are the platform for that. But it's been automatic. You as a developer, you don't have to bother about how everything is done. So developers have access to already installed web servers, database, environment, development, and services and all that stuff otherwise than in high-res. In high-res, if it's in infrastructure of a service, you are just straightforward. You are actually going to be allowed to do your things on your own, the kind of storage you wanted, the kind of services, network, everything you wanted, the configuration you want, you are the one that is going to do that for yourself. So that's actually basically it. So in platform as a service, Typically includes virtualized environment, that is the benefit of the VM environment, development frameworks of your choice. You have a choice of popular frameworks like .NET, we have .NET, we have PHP, Node.js, Ruby, and every other thing you want to run on the internet. So why in the databases? You have provided databases, storage devices, security is iClass provided for you. You could do constant check of scanning your securities, automatic scheduling, monitoring, and report generation for you, scaling up, scaling down, elasticity. All these are actually amazing for you in cloud as a service. So for virtual machines, as I was saying, I think virtual machines is software based instance of a physical server where a guest operating system has accessed emulated virtual environment. So you have access to it, and you are the instance of a physical server or physical computer. So virtual machine are the same as virtual computer system located in an environment where you can install your operating system there, and all the management, all the configuration is being done for you by the Google Cloud Platform. That's the infrastructure providers and the cloud providers as well too. So Apple resource is loaded on the host to run your virtual machines, and you as a virtual guest accessing it, you run your virtual host, which provide your physical resources for you. The resources are being provided for you just like your normal computer. So in virtual machines, you can actually do your configuration yourself completely, whatever you want to do in compared to cloud platform as a service where the configuration is done by the host providers. So to use this, so you can just use web development, install a web server database, and other frameworks that you want to use as well too. So and operating systems and applications are loaded in the guest environment. I mean, everything is loaded with Google, and you have it done at the same time. So in the VMware, like Fusion solutions, you could actually do that. That is the virtual machine ware solutions. So you actually have visualizations in IIS, just like example of VMware that runs on IIS, that is infrastructure as a service as well. So you can actually run Mac OS, you can run Windows, you can run Set OS, you can run VMware, and a lot of things on infrastructure as a service. That's your virtual machines, and everything is gone. So basically, it's actually very important and to know the difference between how everything comes and how everything works. So understanding it, basically, you have to know what SaaS is, what platform as a service is, and what IaaS is. I told you that access different things you access. That's a SaaS, software as a service. Examples are Gmail, Office 360, Netflix, YouTube, Google Search, and etc. A lot of them, those are software as a service. Where we have platform as a service, where we have you just have as a DevOps or as a software developer, you have to deploy your app without on a platform called platform as a service, and you don't want to care about what is being managed. Why the high S is for you to manage everything yourself. So virtualization, scalability, and elasticity, computing, scale up, come down, elasticity when elasticity means when your server is not really running, like there's no heavy load on your app, your prices would decrease, and it will increase when the cost needed as well too. So there's resource sharing and pooling, load balancing, and portability, cloning, and high availability for you as well too. So the third, so we're going to talk about container. Container is another aspect of cloud computing. So in a container is operating system level visualization, just like you have it, a way of orchestrating your code in a container. That's what it means actually. The difference between container and virtual machines, it's very simple. In virtual machines, you install operating system, and it's a bit slower because just like you're building your operating system, you have to load it, it has to come up, and operating system has to come up. While in a container, all your operating system is installed in a container, not in an operating system environment. So, and the container is faster. So it actually doesn't need to load before it comes out. So at the same time, it actually helps. And one of the most popular platforms that runs containers in Google Cloud platforms are Docker, Google Kubernetes, that's GKE, and a few other platforms as well too. But the most common one are Docker container and Google Kubernetes, which we're going to focus on or talk about later on. So a container is faster than virtual machines because it runs its operating kernel provides isolated user face to run in specific application inside the container. So it runs faster. Where Kubernetes runs across clusters as well, and Docker runs in a single node. That's the difference between them, Kubernetes and Docker. So if you actually going to ask about that, we actually talk about that later on. So in the containers, fully self-contained computers inside a virtual machine. So it's a fully self-contained computer which doesn't have to run the operating system. So the contained computers are inside the container and they run faster in the virtual machines rather than a virtual machine just being installed in the operating system and it has to load. So fully self-contained application inside the container runs faster. So containers are faster than normal running or operating system on normal virtual machines. And it have less overhead, faster startup time than virtual machines, more around with examine around Dockers and Google Kubernetes, containers and all that. And they're a huge part of cloud computing as well. So it's actually very, very amazing for you to understand the differences. So execution model in which the cloud provider runs the server and dynamically manage the allocation of the machine resources. So serverless, the first time I heard about serverless, you could actually think, oh, the word serverless. Does that mean there's no server anywhere? There's no physical machines everywhere? There's no, infrastructure anywhere, or there's no data centers everywhere? No, that's wrong. Serverless exists, and there is the location for infrastructure somewhere here. So it's just it's just an execution model in which cloud providers runs the server for you and dynamically manage the allocation of machine faster than you could think. So one of the most example of serverless applications that is very common worldwide is Netflix. So Netflix uses serverless to serve over 7 billion of video hours to 50 million customers in over 60 countries now. So it's actually really amazing to go on serverless because I'll talk about more about serverless and how serverless is different. It's better and can be a bit because it runs on functions, and the functions is only triggered when you call the function. So you're being charged when your function is being triggered. That's one of the key things that makes serverless applications amazing. So your functions can be online, and when you write to your developers write code in functions, and the functions, when only the functions triggers, you are being charged for your cost. So you have to understand that. So knowing as a DevOps engineer, you have to understand what is best for your organization, either to use virtual machines, either it's Kubernetes, containers, or a serverless you want to go on, depending on your mode of application and what is best possible for you. Serverless is another amazing platform, and it's even going to the next, and we are going to talk more about that in coming slides. So serverless, it eliminates infrastructures management tasks such as server or cluster provisioning. It's eliminate that. So everything is actually being done dynamically, and it dynamically manages your allocation of machine resources for you, and it's a bit close to platform as a service because most things are being done for you in serverless as well too. So single purpose functions, deploy code into production. Change when the function is being called. Only charge when the function is being called. You just need to deploy your code, your single purpose functions, and you deploy your code into production without thinking about the manage, and you're being charged when your function is being called. It actually makes it amazing. So more known around excitement around Dockers as well too, containers as well too. So serverless, I'm actually going to talk about a platform that actually makes Docker and containers works in a serverless function later on. So, and they are a huge part of cloud computing as well too. Very huge part of cloud computing and very amazing. So cloud administration providers, I was saying earlier on, we talk about Amazon Web Services, Microsoft Azure, Alibaba Google Cloud Platform, IBM, Oracle, and etc. as well too. So Google Cloud Platform, yeah, it's an amazing thing we are actually been trying to talk about. So it's amazing, and we have to talk about how this works now. And in regards to the introduction of cloud and cloud computing I've been doing, so I believe you have a better example, a better knowledge, understanding of the categories where each of Google's infrastructure fall in their products and services as well too. So we have IaaS. I've talked about infrastructure as a service, which is where you get to manage your CPUs, your storage, your disk, your memory, interfaces for you. And you have the pass for between the virtual machine servers, the cluster management, and you have the serverless auto scaling. And they're actually amazing. So Google Cloud Platform is the amazing cloud providers, and one of the ones that are really amazing for years, over 10 years now. And it's actually really been understanding. One of the things that make Google Cloud Platform amazing is that you could actually work with other cloud platforms. Maybe you want to chip your code from you don't get stuck forever on Google Cloud Platform. You want to work together. It's very interoperability. You can work Google Cloud Platform with maybe Amazon Cloud, Amazon Cloud Computing as well too. Or you can actually say, okay, I want to go out of, maybe I'm tired for now, I want to go out of Google Cloud and I want to move transfer to Amazon, or I want to move from Amazon to cloud. So it's very interoperability is amazing, and you don't get to stuck forever. So Google Cloud Platform is an open source software providers and developers, partners, everybody, third-party software have been part of this Google Cloud Platform. And we have Google Cloud products like services like Chrome, YouTube, which falls under SaaS, which I told you, services, software as a service that fall under SaaS, that are Google products are like Gmail, YouTube, Google Drive, Google Photos, and etc. Google Analytics, Google Search, Gmail, G Suite, Google Devices. And the most popular one you use is Google Search and YouTube Devices. So they all fall as software as a service in cloud computing. And it's actually amazing. Google does a lot of things. And you see that you have different geometric plane. We have in Asia, we have in Europe, we have in Asia and Europe as well, that all the geometrical regions of zones of actually where Google Cloud Platform is, where you can actually access their data centers and many other stuff as well too. So that's the map of how it is. It's a bit small, but you could actually go around it and as well that. So solution continuum as well too. So as we are doing, we say how you actually build apps. So SaaS is actually a very amazing platform where you actually going to focus on today, and platform as a service, the infrastructures where we have Google having both of what they have, and which we're going to talk about very soon. So things we're going to talk about in each of this platform under Google Cloud Platform are Compute Engine, Google Kubernetes, and App Engine. So those are examples of both platform as a service and infrastructure as a service. So we are going to know where all of them fall in the next slide. So you're going to see where infrastructure as a service, examples of Google infrastructure as a service, examples of platform as a service, and where each of them fall under Google Platform. Infrastructures fall under Google Platform as well too. So in GCP, in Google Cloud Platform, you have different places where you could actually connect API services. You could actually do a lot of amazing things, install Google Cloud SDKs, G Cloud, run codes, G utils, and so many other things you have to understand here. So so we're moving straight to a platform where Google Cloud Platform is being run. So Google Cloud Platform, there are 4 ways you can interact with Google Cloud Platform. So we have to understand that before we start interacting with it. So we use Google Cloud Platform, console, and we have the Google Cloud Share and Cloud SDK. So the Google Cloud Platform are just like a GUI environment where we are going to use hosted on, that's the Quick Labs platform. That's the GUI environment where Google Cloud Platforms infrastructures are being run in. And the cloud shells are the command lines where you run codes in command lines. Then you could use the REST-based APIs, which I was showing you earlier on. Then you could actually download the Cloud mobile app as well to do that. So Cloud Console, Cloud SDK, Cloud Share, these are just an example of how it works. When you go to the lab session, you're going to understand better what I'm trying to explain to you here, and you will have more better knowledge on how it works, which is really, really amazing. So we have Cloud Mobile App. So Cloud Mobile App manage virtual machines. You can do your database management. You could see your apps in App Engine. You could manage your bills. You could do visualize your project as well, and customizable dashboard as well too. So you can get it. You can get the Cloud Mobile App for your Google Cloud Management. You can get it on Play Store and App Store as well too. So GCP is global, is automating, and is very high secured infrastructure. So auto scaling, serverless in automating, and it is global, it's accessible everywhere from everywhere you have. So dive straight into GCP. So the 4 categories we're going to talk about, we're going to focus more on Google Cloud Platform. These are the infrastructures. These are Google Cloud Platform infrastructures. So in Google Cloud Platform infrastructures, we have the compute engine. Compute engine falls under IaaS, that is the infrastructure as a service. Kubernetes fall mostly under platform as a service. And we have App Engine at the same time falls under platform as a service. Why Cloud Functions falls under platform as a service. And at the same time, some people call it FaaS, which is function as a service. So they are actually amazing, and we're going to go dive into it. So virtual machines, compute engines, IaaS. So examples of IaaS, infrastructure as a service, this is compute engine and the virtual machines. So we are going to talk about compute engines where you actually have to configure your things yourself, just like virtual machines are, as I was discussing earlier on. Then we have containers. So containers are basically for Google Cloud Platform. We have Dockers for examples, but for Google Cloud Platform, we have the Google JKE, that's the Google Kubernetes, and Kubernetes engine. The Google Kubernetes engine fall under both PaaS and HaaS. So under platform as a service, being automatic, being contained under containerized function, but its infrastructure still runs under IaaS. So, but it's been popular being attached as a platform as a service. There's a lot of controversy around that we actually focus on Kubernetes to be platform as a service as well. While some people will just call it another name and call it CAS, which is container as a service, just like we have serverless. So serverless are basically Google's app engine and cloud function, and cloud functions as well too. So in other serverless, we have the PaaS and the VaaS. So app engine falls under platform as a service. So Google manages all your other app engines, all your infrastructure, your scaling, your security, auto scaling, elasticity, everything for you. And it's amazing, and it falls under platform as a service, that is PaaS. When cloud function is also serverless, but it's actually a way of you building your code, running your code in functions, and it's also serverless as well too. So that's why we call it FaaS. You can call it FaaS as well, which is function as a service. That's Google's cloud function as well. So amazingly, so you see how this is run too. So on Google Cloud Platform, we have major 4 ways we interact with the GCP, which I said earlier on, and Google GCP technology, which has the compute engine, the Google Kubernetes, and the app engine. So in compute engine, remember I told you compute engine falls under IaaS. So IaaS solution under cloud computing is an IaaS solution for those who prefer to manage server instances themselves. You want to manage your server instances yourself. You want to manage your storage, your CPUs, your memory, your network, everything yourself, then go for Google Compute Engine. So you have almost total control of your server, within your server, and its infrastructures as well too. So you go with that. That's Compute Engine. For Google infrastructures as well too, we have Kubernetes. So Kubernetes engine are basically containers. I told you, run containers in Google Cloud Platform. So it's just a way of you orchestrating your code in a container. So environment is managed by Google under administration. The environment is managed by Google under your administration, yes, and you orchestrate your code in a container across a cluster. So it's actually really amazing. It's faster. I told you it's faster than Compute Engine. It loads its own container in a container. It runs across different clusters. So it's actually an amazing platform as well too. So depending on your choice of what you want to run your application or your organization wants, then you do that. So then we have App Engine. So the App Engine is platform as a service solution. So platform as a service solution, GCP is fully managed platform as a service framework. So you just have to tune your code into the cloud. Just tune your code in the cloud. Chip your code into the cloud without worrying about the infrastructure, provisioning, and resources management. You just want to put your code in the cloud, and you don't want you don't want to bother about the storage, the servers, the everything. Google will do that to you. And you just deploy your apps regardless of what language you want to use, Python, Node.js, React, whatever JavaScript framework you want to use, and you can just deploy it on your platform, and Google manage the infrastructure for you and your code running. So you don't need to bother about provisioning and resource management. Google does that for you, and it's quite amazing. And one thing that is another amazing about App Engine, has been running over 10 years. So you want to trust App Engine because Google have been doing it for over 10 years. And it's one of Google's first breakthrough in cloud computing. It started with App Engine, and App Engine is actually amazing. So they've been doing it for over 10 years, and it's one of their breakthrough in cloud computing. So you have to trust cloud computing if you have to do it. It's highly recommended if you have to go with cloud computing as well too. So now we're going to talk about the cloud function. So in cloud function, I told you exactly earlier on, cloud function is completely serverless execution environment or function as a service. You run your code as function, and it executes your code in response to events according to the number of times your function is being run on the computer. You are being charged according to when your function is being triggered. So you have to understand cloud function, and it's actually another amazing platform you can actually use as well too. So comparing compute engines. So you have compute engines. You can see the sample of compute engine, infrastructure as a service. You have Kubernetes, hybrid, just like I said, Kubernetes engine, both combination. I told you in the beginning, I said for me, it's both combination of IaaS, and the platform as a service. So, and Google actually affirmed to it. So it's a hybrid. It's combination of both. It runs as both platform as a service and a IaaS. So his version runs as IaaS, while him himself functions as a platform as a service because it's being managed by Google and the container being run orchestrated in a code. So actually amazing. Then we have App Engine. App Engine is platform as a service. Straight up web and mobile applications container based on workloads. We have App Engine standards, and we have cloud functions, which is serverless. So your functions responding to events, and you are being charged according to your event when your event is being called. So you can run your apps, your frameworks, your languages, and you're amazingly good. So let's talk about Compute Engine. This life cycle of Compute Engine, that's the virtual machines as a Compute Engine infrastructure in Google Cloud Platform. So you have a life cycle from virtual machines to memory to root persistent disks, additional disks, IP system, startup script, and etc. to termination and stop. You can stop and restart your virtual machines as well too. Running through this, so we have the Compute Engine processing. You have the language support, any language, usage module, scaling, auto scaling server. You run on cluster. We have the primary use case, general workloads, container workloads, scalable applications and mobile backend applications you want to build, lightweight event actions, scalable elasticity, amazing. So Compute Engines for several machines, you have network, you have theoretical, you have a CPU you want to run, you have your networking, robust, default, customs one. If you want to use your default custom way it's been set for you, you can use it. If you want to set your own, you can set your own. Usually HTTPS load balancing. So whatever case which actually which you feel it suits you, you can actually go ahead and do that. So the storage disk. So standard SSD and local SSD and an amazing storage disk you can use actually is faster than each other. And one is standard SSD is actually larger, is in more of in terabyte, and local SD is a little bit smaller than that, and it's actually amazing. So you can just whatever storage you actually want to use, which is good. But then changing VM state to running, so you can use you can restart, you can reboot, you can stop, you can shut down, you can delete, and you can do a lot of things around changing your virtual machines to running. And you can VM access, you can install Linux using your SSH and Google Cloud Platform Cloud Share via the QA Labs, which you're going to do later on. Then you can use the Windows SSH to the RDP client PowerShell at the same time if you're using one running on Windows. So that's all about Compute Engine. So straight up to Google Kubernetes. So Google Kubernetes is actually as a function, is a container, as I told you, as Kubernetes is a container orchestrator. So it's means the container runs in order to orchestrate your code. And Antos is another new feature thing that actually comes up in cloud computing, and Antos enables you to run Kubernetes cluster anywhere in both cloud or an on-premises environment. So Antos is another thing you can actually look up to when you're doing Kubernetes, Google Kubernetes as well too. So it allows you to run it in on cloud, on servers. So Kubernetes leverages the simplicity of a platform as a service, and at the same time, its infrastructures are being on IaaS and when just on the cloud. So it utilizes the flexibility of infrastructure as a service and enables portability and simplified scaling. That's why you said Kubernetes are hybrid, both combination of platform as a service and IaaS, infrastructure as a service as well too. So Kubernetes versus Docker, you might actually want to talk to it, so I decided to put it for you. So a fundamental difference between Kubernetes and Docker is that Kubernetes is meant to run across a cluster, while Docker runs on a single node. So both of them does their works awesomely. They're amazing. A lot of people use Docker, and Kubernetes is most commonly used as well. It can be used with Docker, but it can also be used with any container runtime. So Google Kubernetes, that's Google GKE, engine is actually an amazing platform to actually look into as well too. So serverless function, this does not mean no server. I told you earlier on, it still uses a server, and this is the process of running your code without caring or thinking about the server is run. So you just orchestrate your code online. I mean, you just run your code in functions and you are good to go. So cloud functions basically can be known as function as a service as well too. Data processing, webhooks to respond to HTTP triggers, mobile backend functions, and a lot of amazing functions in it. So App Engine versus serverless. So App Engine is better suited to applications which have more numerous. You might want to think like, okay, why not App Engine? Why serverless? Since they're almost similar and all that. So, but in App Engine, it's suited because you want to trust Google App Engine because it has been over 10 years being managed by Google and it's amazing. So App Engine is better suited to applications which have numerous pieces of functionalities. And at the same time, you have the thing behaving in various manners, interrelated or even unrelated ways. So you're being billed as far as your code is being deployed. In cloud functions are more specifically single-purpose functions. So single-purpose functions, you can set to run in serverless. In your whole app, you can put a part of your function of your app or function of your code on serverless to be running. So that function, if you know it does not really, it's not useful, and maybe when you're running in an app engine, you only want to call that function. You only want to call it when it's being called. You only want to use it when the function is being called. So you can just put that function in a cloud function under serverless. So a single purpose function that responds to some event. So when the function is being called only, that's when you're being charged. So it performs some specific actions when only that function is being served. So deploy your code as function, be only while your code is running on the cloud, and can run containers in serverless requests. So we have an involvement of serverless, which is Cloud Run. So Cloud Run can run containers in a serverless request response function. So it's just like you having a Kubernetes running as a serverless. So that's where Cloud Run comes in. So Cloud Run runs containers in a serverless request response function. So you can actually read more about that if you actually want to know how to run Kubernetes as serverless as well too. So storage devices, storage. So you can access. There are four ways you can interact with your storage devices. Different ways you can interact with your storage environment. So you have to understand which one best for your database you want to use. That's your storage options. For cloud data options, it's no SQL. You don't need to run SQL. You only get started. Google manage getting started with App Engine applications. Google manage everything for you. It's on the App Engine and it's run in petabyte. So we have cloud big table. You've been hearing about Qtable. No SQL at the same time. It's heavy. It's basically good for read and write applications, events, and or maybe you want to use you're building an apps considering analytical data. So you can actually use cloud big table when you want to use that. Or you want to build an app regarding art, financial, IoT, then you are being highly recommended to use cloud big table. So cloud storage as well is blob store, like all images and all that. If you're building apps around a lot of images, structured and unstructured binary, because you're going to convert your images or your blob binary store to structure to binary form objects. So it could actually can work faster and it will tell on your cloud storage. So your cloud storage being preferred to use on a Google Cloud Platform is cloud storage. So images, large media files, converted to binary forms, files, and backups. So use global arrays. So actually, it can also be run in petabyte and a lot more. So we have things like around from kilobyte to petabyte to gigabyte to terabyte to petabyte to even yottabyte. So we have yottabyte at the same time, and we have zettabyte, which is the last one. I don't know if you're aware. So all the storage devices have their own different functions, and they work perfectly according to their storage sizes as well too. So let's talk about the popular cloud SQL and Cloud Spanner. They are like twins, Cloud SQL and Cloud Spanner. They are relational SQL. They're like twins database. So they work together. It's just like, oh, one comes after one in order of sense, like in the twins form, one comes before one, and one is bigger than one. Twins, some twins we see why some is bigger than one and one is larger. So and they have different purposes. In Cloud SQL, you have web frameworks, existing applications. In large scale database applications, is greater than 2 terabytes, while that one is less than that. And user credentials, when you want to run things like user credentials, customer orders and other simple things, applications, you could use cloud storage. And cloud storage when you want to add non-IR thing, whenever IO global consistency is needed as well too. So the popular BigQuery again is relational SQL. You can run SQL on it as well. Interacting querying, offline analytics, and data warehousing as well too. So each is actually very amazing for you to actually work on. So choosing among cloud storages depends on the app purpose, your regional, nearline, full line, whatever things you have to access this. I have some couple of blog posts regarding nearline, code line, where I explain basically more around multi-regional, regional, nearline, and code line. So I'm going to share it after this section so we can actually read more about that and understand the differences between them. So a shift into DevOps for beginners. You actually know new technologies keeps coming out and we keep doing amazing things and the involvement is actually really great. So 4 minutes to my time. So it's actually a shift to you need to have a shift to DevOps as a beginners, understanding how you can best work on your cloud and how your cloud functions can really work perfectly and understand you just going beyond being a software developer and understand how cloud functions well, becoming a DevOps engineer or whatever it is. New technologies is coming like Cloud Run and tools and cloud computing keep advancing. Google Cloud Platform Computing, amazing platform, keep advancing and it's something you have to check out and use so that you can have amazing application running and scalability, elasticity, speed, and a lot more. So that is it for my section. For the section, for the theoretical per section, and you could actually, I'd love to hear your thoughts. Share some tweets. I think organizers do a lot of things around tweets, encourage more tweets, just screenshots of where you are, slide sections, tweets around social media, tag Dsc Bvp, and do a lot of things around social media as well too. So if you want to reach out to me, that's my website, and that's an email, slick@meetslick.com. You could send my email. You can give a shout out to me on Twitter, on Instagram, or LinkedIn, and other platforms. So additional resources you could try check out cloud.google.com. You could read my personal blogs that I do more, freshjobs.com/cloud. You can read cloud, my cloud write-ups there. Then you could actually check out Quick Week Labs for our hands-on sections, and it's actually going to be beautiful as well too. So be inspired. Imagination is more important beyond knowledge. So thank you very much, and we are going to go back to quick lip section after Emmanuel takes the Q&A section. Thank you.
Okay.
Over to you,
So
Emmanuel.
that was awesome. Like I personally got got to know a lot of things that I wasn't so sure about. So that was awesome. We have only one question for you, Slick, right now. Sorry, can you present it on the screen? Um, so yeah. So Ishita is asking what is the relationship between pass and containers like Docker. So it's like if you would like to take it.
Okay. Thank you for that question. That's a nice question, and I think I've said a lot of things around this. Platform as a service. While I was talking, I told you containers are hybrid. They are not just platform as a service again. And they're both platform as a service and infrastructure as a service as well too. So containers are like Docker, Google Kubernetes, JKE. So you can see the relation between them. Platform as a service is a cloud computing infrastructure, while containers as well too are platform as a service, because the Google, for the example, we have the Google Cloud Platform, that is the GKE and the Dockers. They actually run as a platform as a service because Google manages the containers for you. You just have to chip your code inside the containers. So, and this is what platform as a service do. That's the rationale between them. So, and the same thing with Dockers. So Dockers run as platform as a service as well too. But their main infrastructures, based infrastructure, like a foundation infrastructures, still run under infrastructure as a service, which is all the resources being provided by them as well too. So there are a lot of amazing relational difference between them, both PaaS, containers, and Docker as well too. And I inside one of my slides, I told you the difference between the containers, and they're almost the same thing. Google Kubernetes containers are Dockers are containers. So, and they are also runs on platform as a service. So they are relations together.
Mm-hmm. Okay. So one of our one of the student is asking, can we have the presentation that you were presenting?
Okay, yes, sure, of course. I'll share it with Mandri after the section. So you have
Yeah.
link to my presentation.
Yeah. Cool. So okay. Um. Okay. There is one question as well where people are asking like, which is better between AWS and GCP. So if you
Okay, okay, which is better between your cloud and AWS?
yeah.
This is actually a very interesting conversation. Trust me. I will tell you that any day I'll tell you Google Cloud Platform for me, my own opinion, because of the amazing. I told you why people choose Google Cloud Platform. It's interoperability, and it doesn't get you stuck forever. You just want to. It's faster. You keep moving. Trust Google engineers. Keep working on it daily. Keep improving new features coming every day. Functions, faster speed, access to resources, access to getting started, free labs, a lot of credits or encouraging Google Cloud for you to get familiar with it. So trust me, there are a lot of different ways. There's a tweet recently that came up on Twitter for which one is better than Google Cloud Platform. But trust me, Google Cloud Platform won that because a lot of people actually prefer Google Cloud Platform, and I told you interoperability to go work with any platform. It doesn't get to stop forever. You can move from Google Cloud Platform if you're tired, and you can do a lot of things can go from one infrastructure to another. So it's quite amazing for me. Google Cloud Platform.
That was great. So I think that was it. We have already answered a lot of questions in the chat section as well. Like one of there was a debate as well. I would like you to know that is YouTube SaaS? Is YouTube follow SaaS or is it fast?
Sorry, can you come again
No.
in Mandarin? I didn't hear that.
Yeah,
Sorry.
I was saying there was a debate in the chat section as well about YouTube being SaaS.
Oh
SaaS.
yes, yes. Absolutely, 100%. YouTube is similar to Netflix, like is a streaming online platform where you stream videos and all that. So it's a SaaS, software as a service. It's a service being offered to you over the internet. So I'll make mention of it in my section. It's a software as a service, 100%. So just like Google Search, the most popular Google product under Google Cloud Platform that is software as a service is Google Search and YouTube. Other ones are Google Analytics, Google Drive, and etc. Google Docs, many of them, 100% SaaS.
Yeah. So I think that was it. We can continue to our next section, part two of having hands-on. Um,
Okay.
yeah, cool. So Shaurya, you can present like screen for the hands-on section now.
Thank you. So, so in our answer section, so we are going to basically talk about, we're going to start with creating virtual machines. That is a computer engine on Google Cloud Platform. Then we're going to interact with it. So I hope we all have access to the platform so we can just get started with it. So let me share my screen to this. Mm, Creating virtual machines. Okay, so
Yep, it started.
yeah, so we're going to start with creating virtual machines. So um, if we have access to this lab, we can just follow up creating virtual machines. So we're going to use 2-week labs for this platform. So I'm going to take you through Q Labs is a platform where you access where you actually have access to Google Cloud Platform, and you pick labs or you pick you have credits and you want to run or ship your apps via through the Google Labs where your app is being run. So if you can see my screen, so actually getting started with the Google Labs. So I'm just going to click on this to start the Curate Labs. So we're the first thing we're going to do is to create a virtual machine, and this is how we're going to create the virtual machines. So we're creating a virtual machines, and we have 1 hour to do this. And so you have to follow me as I'm doing this. I hope you have access to your phone. Access the lab via the links above, and we're doing creating your first virtual machines. So students, you as a student, like I'm a student now, and I'm actually trying to access the lab to set up my virtual machines. And via setting up my machine, I'll take you through the Google Cloud platform via the Quick Labs. So click on the virtual machines and access it now. So quicklabs.com, that's it. Then follow the links to the lab section and find creating virtual machines. Then you start. So I'll just have to click directly. Okay. I might need to share my screen completely because I'm not going to work on only on okay, so sorry. So most likely it's been advisable for you to access via your lab via your access your lab via your Google Chrome Ignito. So so that you won't be charged to your partner account. So make sure you access your lab that link via Google Ignito so that you will not be charged in your account. So make sure you remember that before you log in. Okay, so I'm actually going to completely share my screen. Sorry, I'm actually going to share. Okay, so okay, nice. So you can go now. So the first thing I'm going to do, you're going to check by the left here. You just click on Open Google Console. So you click on Open Google Console. So it brings you here, and when it brings you here, so it takes you here. Then you put your login details, which is what you get from here. Student, you just copy this and put as your email. That's your login details. And you come back here and copy your password. So for every project, there's global GCP IDE. So global GCP IDE is this one. You don't need it for now, but when you need it to run, sometimes you might need it. So you come here and you accept the conditions. You confirm. So so you confirm, you accept, If you want email, country you're coming from, accessing it from India, from whatever part of the country, you continue. Then you, and this is the Google Cloud platform, where which we accessed via Quick Week Labs. So via the Quick Week Labs, and we have this, which is actually very important for us to know. So this is the dashboard, and on the dashboard you see different things like your project name, your project ID, your project number. You can check out the settings in this place. You can check out the settings for your platform. You can check out the settings. You can see your project name. You can see your project layout, your everything. You can shut down this project if you don't want it again. Then you can. We are not accessing it via home. We are not accessing the IAM. IAM is for security. So we have the REST APIs here if you want to request. So you have, if you want to customize your page, you can customize your page. So you want to check your activities or what you've been running recently, or your ID or your project on your ID, then you could actually check all of them here. You have been advised to basically have a strong internet so that you can actually see everything you've been doing, everything running and all that. So yeah, we have the marketplace. We have the marketplace. The marketplace is where you actually have access to things. You can install different things, web servers, Apache, MongoDB, Traffic Manager Enterprise. You can just search whatever you want to search here, and you have access to whatever you want to install there. So we have the billings, you can check your billings, you can see your API dashboards, the support, the high end, that's the privileges, organization privileges, knowing to know who to give access to, manage your organization settings, service accounts, and everything you need to do. So this is security, checking the security detection, data loss, backups, access approvals, scanning, and everything. And this is Anto that I talked about, managing Kubernetes, using clusters, management, and all that. Then this is the compute infrastructures of Google Cloud Platform. We have the amazing app engine, which we started with. And this app engine, we could actually do a lot of things around it. We can access this through the Cloud Share. So I'll talk about the Cloud Share soon. And we have the compute engine. The compute engine is for creating virtual machines, VM instances, every other things you want to create. You're going to see it now. Then you have the Kubernetes, the almighty Kubernetes, really illustrating your code in a container. We have the cloud functions, that is serverless. And we have the cloud run that I told you, you run containers in serverless. So that's the cloud run new. And we have the VMware engine as well. So we have the Firestore instances, the backup, storage, data transfer, and we have the databases that I took you through earlier on, the big table, the data store, the Firestore, the Firestore, that's the data, the Firebase, that's Firestore, memory store, Spanner, SQL, and a lot of things. Then networking parts, the BCP network. So this is just a piece of overview of Google Cloud Platform, basically what we're going to do. And we're going back to our lab. So we have 10 minutes gone. So the first objective of this labs is to create several standard VMs and create advanced VMs. So we're going to create VMs in this lab, both on using the console and probably not the cloud share as well too. So so in the console, you navigate to compute engine, that is the VM instances that I took you through earlier on. So if you have any message, I'll be coming back to check messages. Okay, no message for now. Link to virtual page. Okay, so I'll just continue. I'll just continue my page. So so we have name. So you have to go to navigate straight up to compute engine. You remember compute engine? So we pass through compute engine here. So you can click directly, or you just click on VM instances. That is virtual machine. So VM instances is what we are clicking on. And when we click on VM instances, we are creating this. We're creating this. So we're creating a VM instance. So for the type name of the instances, you have to be sure of what you're doing, because there is a score here, which is checking your progression, and how you're progressing, how you're doing it very well. So you can check your progression when you actually pass through one. So For region and zone, you select US Central and US Central C respectively. So for the name, however, for the name of the instances, over to the mark icon about the name of the instance. So consider a properly formed name. So I can just say, click on create. So I click on create. Preferably you have 4G, it makes it work faster. So and I'll just say I'll just name it my VM it must be small letter BVP, that is VM BVP instance one. Into instance one, so no space letter and no capital letter. So you remember I told you about virtual machines, that you decide your storage, your regions, your memory, whatever things, and this is where we are right now. So let me check if I have a message, if I have anything. You can drop everything in the chat if you have a question. Okay, VM instances means, and why are we creating every lab? We are creating, and why we're creating in every lab of the quest. I don't really understand the second question, but VM instances are just, I told you virtual machines are instances, they're instances of a computer system. So yeah, why is called VM virtual machine instances? VM instances is virtual machine instances. It means you are creating an instance of a computer, local computer system. So just like you have your laptop on your house, and it has a storage, it has a memory, and it has an operating system. So the instance of your laptop is what we are creating now, and that's why it's called VM instances. So we want to create a VM instances now. We are going to declare the storage, we're going to declare the memory, we're going to declare the RAM, we declare the host, where we want to host it and all that. So, and we're creating in this lab. So because it's the first one we're creating it, because this is the first one we're actually focusing on, which is the compute engine. We are actually going to do app engine after this. If we have enough time before 2 p.m., we can be able to do Kubernetes or maybe some other time in labs. But visually, we're going to focus more on the compute engine and app engine after this. Goes after this. So going back to the lab. So because we're running out of time, so and I have to complete this lab 15 minutes time. So I have to be a bit faster. So just be fast with me. So they said with me, they said we should pick US Central 1 and US Central C. So we go here, that's the region we are picking. US Central 1, Loha, US Central 1. So we're picking US Central 1. So we're picking US Central 1, US Central 1, and we're picking C, US Central 1, C. Yeah. So that's what we're picking. You can see other regions, North America, South America is US West. You have Europe and we have Asia. So that's the three basic regions that Google data centers have been working presently. We have the Asia, we have the Europe, and we have the America. So we're focusing on what they as the lab instructed, so that we can pass the lab. You can try to choose anything, but we have to pass the lab, so we have to follow the lab. So for machine series, for machine configuration, select series as N1. So we're selecting series as N1. That's the first generation. So under the machine type, that's just the way we have. So in the machine type, we have for the machine type, know that the menu is also CPU amount of N1 and that N1. So the only means the parameter you want. So the machine type is data is right now machine type list to see the breakdown of estimate cost. So you can actually see the breakdown of estimate cost. But what we are picking is N1 standard for. So everyone has the cost. You know, you have to pay for what you want to use. So you can see different ones. You have your N1 standard 1, you have N1 standard 2. So everyone, all of them has different costs. So depending on what you can afford, you are being advised to use depending on what you can afford. So for this one, we are picking N1 standard 1. So N1 standard 4, sorry, 15 gig. For machine type, so click on N1 standard 4, 15 gig. So N1 standard 4, 15 gig is what we are picking, 15 gig memory. and we have the 4 VPU running in the computer system, and we have the for the machine type. Okay, for the boot disk. So click change. So when we click change, we put Debian Linux 10. So we're installing Linux. We're not doing Windows. So we're leaving this one as CPU is there. We don't need to change anything here. So we are picking Debian GNU Linux 10 Blaster. So Debian GNU Linux 10 Blaster. So we are choosing Debian. So we can see CentOS. You can see operating system. Just like I tell you that we're creating operating system in a virtual machines. And that's why it's called VM instance. It's an instance of a computer system. So Red Hat, SQL, everything, Ubuntu, Windows servers, you're going to use DP to actually install that. So you're doing Linux, and we're using Debian Blaster, Debian 10 Blaster, and we just have to select it, and we are good. So Compute engine, is there anything they want us to change here? Nothing. Click Debian, click management messages. So let's say click networking and edit icon, select non-external ID. So we are actually going to click management this. So we are actually going to click this management for us to see what we are actually going to do. So in that, if we click management case solve relation, you see different thing, but the focus, the main thing we are actually focusing on, actually checking the networking aspect, and you can actually check your billing price. If you are bill in instance, you can do a lot of things around it. You can play around whatever you want to do around this. So in this place, we are clicking on the networking aspect, just like I said earlier on. So the networking aspect, and we're going to change this to network interface. Okay, so they said, so when you click the click management, you go to navigate to networking, then you click the network interface edit icon, then you select none for external thing. So just navigate straight to your networking interface, then you click default, then you will just navigate to external IP. External IP, then you will just pick to disable whatever domain you actually want to do. You can play around it. You can check if what you want to do, if it's ex-referral, if it's primary IP address, subnet. Sometimes we need to change our subnet depending on what routine we are actually directing it to. So, but we are just focusing on interface and network added, and we are selecting the external ID. So the only thing we're changing here is the external ID. So the external ID, and we're going to click on none. So everything done. So when you click on none, the external IP, you click on none and click done. So when we click on done, we go to do. So if there's any other thing we need to click, let's just select none, click on done, then leave the menu settings, just click on create, and your event will be created. So another thing we have to check is, you have a specific name over. Okay, then we click on create. Let me check if you have a question. Okay. So our VM is rolling, it's coming up. So we have the VM virtual machine BVP instance 1. So I'll later on we're going to talk about how we can access it through the cloud share. This is activate cloud share here. So it's marked and our instance is being created. So we can go back to the lab and check if we're able to do that. So on the VM instances, click on the name of the VM and locate the VPU platform and click on edit. So we're going to do a lot of things around this. So you can just check the VMs. On VM instance, you can click on the VM instances. So click on the name of the VM and locate the VPU. So we just click on this. The lab is a bit having more stuff than the normal labs. I'm just watching time. I hope you'll be able to finish up. So in the VM instance of the machine, so locate your CPU and note value and click edit, just notice what is running around it. Just examining, just check, examine the availability policy, but we don't have time to do a lot of things around that. You can just click the edit. You see the edit, just check around what is happening, your GPU, get familiar with the environment, check your firewall. You might need to know it once in a while. You check your, what other thing they said us to check, availability policies, and so many other things that we can just need to check, but it's not really necessary. So you can click on cancel. You don't need to change anything there. Just click on some cancel, then VM instances, clock login. You can click on login and check your progress. So I don't want to do that because of time. So just play around your stuff. Click on it, play around it, check it, understand some things, and afterward, take up this lab again, try to see what they are checking, and you can see that we have successfully done the first one. So now we're going to compute engine VM instance. We are creating a VM instance, and we're creating this. We can track our name. So we are still going to compute engine, and we are still creating another VM instance, another VM again. So create instance. You can just click on create instances like that, using that banner, using that click. So inside the hit, so you can type bvp2 bvp2 instance minus blah blah blah. So we have the name, and after we've done that, then we can click on the Europe West 2. So we are selecting Europe West 2 this time around. Europe West 2, that's located in London, and Europe West 2. Then we have West 2 minus A. So we are picking West 2 minus A. So after West 2 minus A, we are changing the series should be N1. The series should be N1, first generation, and the N1 standard 2 VPU 7.5, N1 standard minus 2, N1 standard 2, N1 standard 2, 7.5 gig. So memory, you can change boot disk, quick change, Windows servers. This is going to take a lot of time if we're going to run the IDP. Okay, so we can just change it to Windows Server. Change to Windows Server. So this is new in this lab. Before there's no startup for Windows. So we're just going to change this to Windows Server, and when you click change to Windows servers, then we are picking Windows Server Center Data Center 1, SSD persistent disk on this. So Data Center Server 2016 Data Center Core, 2016 Data Center Core. Okay, so Windows Server 2016 Data Center Core, and SSD persistent disk, SSD persistent disk. We change it to 100. The disk size to 100. So we are creating operating system now, just like you have operating system on your system, your local device. This is what we are doing now. So we're creating Windows operating system on a virtual machine, and we click on select down. So that's the same thing we do. So we go to for firewall, enable allow HTTP and allow HTTPS. So because it's Windows, so we have to enable allow HTTP and HTTPS. Most likely for Windows, that's what to do. And that's all. And you click on create. So instance is being created. So click on the name of the Windows VM to access the VM instance details. Okay. So you don't have to have a valid password for this Windows VM because you need a password to authenticate in every Windows. That's why I don't really want us to run it. It's time consumption when you're creating Windows. So you cannot log in Windows VM without a password. So you need to set a password. So you click on set and you provide a password for it. Then you go to this and go and download RDP on your Chrome. So RDP will have to be triggered, and that's where you platform you're going to run your Windows on. That's RDP. So it takes a lot of time. So this is the Windows, and you can just click on set password. This is it. You can see me set password RDP. So this is my student name. You can copy your student name somewhere else, and your username still remain. So new password has been generated. You see. So you can just try to copy your student name. You might need it, and your password in a notepad because you're going to need it. So copy it and save it in a notepad. I hope we're following. Let me see the screen. Okay, great. Great. So, okay, great. So let me go back here. So close. So your password have been set and it's been secured. So then you come back, then you click on RDP, but we don't need that. So what we need to do is that if you don't have RDP on your lab, so you click on this. You click on this to install RDP, but I have the extension already. So you don't need to, I need to sign in. Am I already signed in? Okay. It can be, the RDP will be a problem because you have to go and check it on your normal browser during running. So you can just check your progress when you're done. So I have it installed already, but this is where to install it. If you don't have it, I can just copy it in the chat box. So I can just provide it in the chat box. Hopefully, I can't find my chat box. Okay, I don't know. So yeah, you can, this is the link, you can copy it. I sent the private chat to you, so you can just copy it and send it. So we have not gotten to Cloud Shell, so we'll get there. You can run by the Cloud Shell your VM instance through the basket in QLab. Yes, that's true. Can we create a VM instance through Cloud Shell instances? Yeah, it should be in this lab. We're going to do that. So we have not gotten to that. So we see that I've created Windows and I'm fine. So now I'm creating a complete engine again, and I'm going to use code. I'm going to create, so type your name, create code, and all that. So connect my SSH to these VMs, and I'm going to, okay, I think it's not this lab, but we can actually use virtual machines to connect to that VCS. So, but let's just do the last one in this lab before I can. This lab does not allow us to do that. So let me just do the last one. So we're creating another instances, and you're typing your name. You're using this, and we're using Besta Buster. So we want to connect us. We want to see each, and we want to know how to use CSH right now. So we have to click on this again and create. Create instances. Okay. So just say bvp cloud. So, and the only thing we just needed to do is US West 1, US minus B, US West 1, US West 1, US minus B, US minus B, West 1 minus B, N1, custom, N1. So we're doing N1, machine type, series N1, then machine type is custom. Okay. Okay. Machine type is custom. So we have calls. So we are creating this, we are editing it ourselves. So this is just a third one to let you know how you can create it. Then we are 32 gig memory, 32 gigs, so you can adjust your memory to yourself. So it's showing us how we can then we have the Debian cluster. Custom. So okay. So we have the Debian clusters. Nothing more we're changing, and click on create. So that's a 3. That's the third one we just created, and so we're going to see each after it's been done. So for the people that have been asking about CloudShare, this is how CloudShare works. So I activate CloudShare via this place. This is where CloudShare. See what I click? I click this, and I click on continue. So I could actually run around my CloudShare here. So we're going to. We don't have much time, so I'll actually have to create. Um, so command. So I just want to show us um, few things. So if we needed to actually create an instance via things, I will just take us through how to create it. I'll just have to share my screen, but I'm not actually going to do that directly because of time. Okay, um, so we can just see H to this lab. So we just see H to this, just like I said, this is compute engine. This is the CloudShare environment. We can create VMs via this platform, via CloudShare. And we can create another VM, dedicate the storage, the everything, the name and everything. We can actually do that via that platform. And maybe in the next slide when I'm working with App Engine, I can actually try and work on that. So 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 we just add to CH here. That's what we are asked to do. So we CH is a server where we used to interact. So we just have to use the command to via SQL custom VM. So use memory to swap. So we just want to interact with our CSH. I don't know if my screen is. You can see my CSH screen. Okay. My CSH screen is not showing. Sorry. I will have to share my screen completely for that to show up. Okay. Okay, Imandri, you want to say something?
Yeah, I was just wanted to tell you that we can stop after this lab because there's some more things that I want to tell
Okay.
about the challenges there. So
Okay.
otherwise, I will give you the overview. I will give the overview of other two labs to the audience.
All right. Awesome. Awesome. Okay. So we're almost done with this lab. So the only thing we just need to do is just to SSH. So in 2 minutes we're done with this. Then I give overview of all the labs. Then we wrap up. Then I'm
Yeah.
done for
So
now. Okay, great. So so we just have to SSH. So when we click on SSH, we click on free. Um, so then we just have to follow the line and the pseudocode, copy the pseudocode, then okay, sorry. I'll have to share my screen completely so that we can do this together. Okay, so this SSH. So you click on free, then you click on this pseudocode dummy pseudocode. Then you're working on this. Okay. Then to verify the number of processors that runs on the command line too, so we just had to use the nproc nproc command. So you see different things. So look for the Debian rows, you can see the handles and everything that
Like,
goes on. So
hi. Like,
we
can
can
you
just
zoom in the screen a bit?
hello, hi.
I was telling to zoom in the SSH screen a bit.
Okay, let me. Okay, the screen. It was not added. I shared the screen, so I think it was not added too. Okay. Okay. I think this is not the screen. Sorry. I have so many screens already. Okay, please, can it be added now? Okay, great. So you just have to SSH through this platform. You SSH, then you put on this code. Because of time, we will not be able to run out that. Then we run out to code this code, and you check if you are done with the cloud. So you can see my score 1515. I was able to run the cloud all through to that. So that's the review of what happened. We create a cloud, and we have done how to create cloud in different ways, editing your compute engines and creating a virtual instance, like an instance of a computer system on your systems. And we are good with the lab. So when you're good with the lab, you can hand the lab. So I'll just give a walkthrough of App Engine Lab. So the walkthrough of for the App Engine. So you might not be able to go the walkthrough. So let me just display it on my screen so you can have a better view of what I'm going to show. Because of time, so this is App Engine fundamentals. So the lab is just basically normal way you start, you do this. So, but in this, remember I told you in App Engine you have to have your application built already. You just want to chip it online and you want to get it started. So now this is where we're going to interact with CloudShare. So use your CloudShare to interact with App Engine. Unlike you can access Compute Engine via the normal Google, Cloud Console. But this CloudShare we're going to use that I showed you where. So you put your code gcloud hotlist. So you confirm your credentials pointing to your username, your ID, I mean your global ID, that's Google Cloud project ID, pointing to your user, then your name credential, you confirm it, then you set gcloud config list project. So that means you listing out the project under that place. So when you are setting your project, you are pointing your lab to your project instantly. So project equals to project ID, and this is it. For example, this output will show you when you click use on this lab. So now you're going to initialize App Engine because App Engine is what Google does. Google manage everything, so it's below it, and you want to initialize it. So initialize your Google App Engine with project and choose its region. So gcloud app, create this, and you put your project ID. After putting your project ID, then you have your app, your project already on GitHub. So you need to clone your GitHub inside App Engine and bring it inside Google Platform and put it inside App Engine and deploy it inside App Engine. So you clone using this command line, you clone your Python language. This is a programming language on GitHub already. You clone it. After you clone it, then you cd to the hello world of the Python program. You can do this, run this on your own. Then you sudo apt get update. Sudo means another platform. So when you sudo, it gets you the app update, the app engine update, everything, the update, the recent app any update runs in your profile. Then sudo get install virtual environment. So install your virtual environment. This code install your virtual environment and your virtual environment for Python 3 environment is being done and activated here. Then you install the requirement.test. So you're asking a test inside your app and python.main.py. That's you're accessing a file in your Python app. So you can preview it and check what you want to. So inside it, after running all those things, you'll be able to preview in a web page using the, you copy the URL and you will see that hello world, your hello world is here as well. So to the end of this one, you just keep Control C to abort where the CCH, the cloud share you are actually working on. Then you go back to, then you can actually proceed from actually after doing this, you can proceed to task 3, you deploy and run everywhere on App Engine. So your app is on Google Platform, but you have not deployed on App Engine. So you cd to where your app is, your Hello World app is, then you gcloud app deploy. Then you deploy it to the App Engine where Google manages all the infrastructure and everything for you. And you are being prompted yes or no. You click on yes. Then you launch in your browser, gcloud app browser. Then gcloud, your Hello World is run on the QLab section. And you deployed it successfully. So when you're done, you can decide to disable it since it's a demo app so that it will not count on your account. But if you're running it through Google Cloud, through GCP, through Ignito, then it won't count on your upload. Then you can disable the app and the app ID. So that's how simple you can create App Engine. Very straightforward and amazing. So because of time, we will not be able to exceed this. And that's basically end of the section. Subsequently, we'll share your resources, the lab, all other labs you can actually run on your own, and you'll be able to get whatever thing you actually want access to, the access of what you want access to. And that's it for me. Thank you, everyone. You can drop your questions. If you have personal questions, you can drop it. Yes, we can create it. There's a lab. There's a lab that before this lab I'm running, as we're supposed to create it by command line. It's very straightforward, just like the way you are pointing your app engine that just run through now. Gcloud, deploy there's a command. The command line has a list of the name, the VM name, the storage, the Debian storage, the Linux, you put the size, the everything, the RAM size, everything you want to create at a single enter command, a list of commands, and you click enter, then you create your VM instance instantly. Very easy and simple. So I will share those resources after the section, and I will a link to a lab that shows everything as well. You can demo it on your own. You can create it. So any other questions? Imandri?
No, I don't think there is any other question.
Okay.
People are just asking about the giveaway now. So, okay, that was awesome. We have learned a lot from the whole section, and that was awesome. I was that I don't think there's any more question. Shraddha, is it there? I don't think. So okay, cool. So I can continue now. And thank you so much, Fleck, for being here. We are so honored to have you, and we have learned a lot from you. That was super awesome.
It's a pleasure. Thank you. Thank you for having me. Thank you, everyone, for having me, Imandri. And it's been awesome with everyone, the organizer. The organizer, thank you very much. It's actually amazing having everyone here. And you guys I must say, you guys have really done a great job. And I have to take a shout on this. So everyone has to be excited around this. And I just want to say that the learning does not stop here. So you have to keep learning, and you have to understand that it's important for you to know a lot of things around Google Cloud Platform. You just don't have to stop here. and why you're not learning anything else again. So it's important
Great.
for you to know that you have to continue learning. And kudos to all the one organizing this. Thank you for having me, Mandu.
Thank you, Clay. So, okay, we can continue with the 30 days of Google Cloud challenge now and what it is. Um, so you can further continue your journey with whatever Slick taught you and the whole hands-on session. You can all continue with learning more on the hands-on session that 30 days of Google Cloud challenge has to offer you. So we have two tracks here. First is cloud engineering, and second is data science and machine learning track. The track one includes all the basics that you need to know about cloud, and you can just go to the link that is gcp.dsc bvp.dev and have a look on all the cloud engineering tracks. Further, we have data science and machine learning track, where you will get exposed to machine learning APIs and more works like more tasks and BigQuery and more machine learning models. Further, what I will like to tell you that before this year, we had quests that you had to complete, but this time you have challenge labs. Challenge labs have a special lab called like a challenge lab is a special lab which tests your capability of the whole thing that you have learned throughout the track and throughout the quest. So it's basically at the end of the quest, you will earn a skill badge after completing the challenge lab, and you can show off that skill badge on the internet. So how do you earn skill badge? It's you show your how do I earn that? I just completed the whole quest that I learned and then I completed the challenge lab, which tested my knowledge, and then it is there on my profile. Further, what you will get from the skill badges, it's like you will gain the hands-on experience. You will prove then you have the challenge lab in your hand, and that can show you how proficient you got. Next, you will share your accomplishments. So okay, so we have the prizes for students only. That if you complete only cloud engineering track, you will get one T-shirt and sticker pack and a participation certificate from Google. Second up, if you complete the machine learning track, we have participation certificate from Google, T-shirt, and a sticker pack. And if you complete both the tracks, that is machine learning track and the cloud engineering track, you will get two T-shirts plus a sticker pack plus a laptop bag and a participation certificate from Google. So if you need any kind of help, what you can do is first you have a online chat support on the main quick labs page only that you can access, and the replies over there are quite fast. So next up, you can contact to DSC support at quicklabs.com. You can and the team there will quickly respond you if you have any query about that. Next up, you can reach out to your facilitator for BVCOE. I am the facilitator, and you can reach out to me. I've also provided the WhatsApp group, like we have this common WhatsApp group, so you can reach out to me from there as well. Next up, you can Google it. The answer to all the questions is Google. So you can Google it, and you can review the support documentation at cloud.google.com /docs. Um, task for this week, like you can, as we have exam, you can continue this till 5th of November as a deadline. Before that, this all will be counted, and you will be eligible for the rewards that Google Cloud team is providing us. So you can complete all the quests in the cloud engineering track and take all the skill badges simultaneously. Then these are all the skill badges that you will get at the end after completing all the challenge labs in all the tracks, all, after completing the first track. Okay, cool. So we have next up data science and machine learning track. You can complete these tracks and you can take the skill badges again, and have the you will have these skill badges then afterwards completing all the challenge labs. Next up, you share your achievement. Do not forget to share your achievements with us. We will be happy to see like people are achieving this much, and if we are here to help if you have any difficulty as well. Share your achievement. The Google Cloud team will review it, and it's a great accomplishment where you will get to know. Okay, so it's time to announce giveaways. We have five Angelayo product courses worth 10 USD each that we will be giving away from today's session, and there will be one lucky winner who can get 500 USD worth JetBrains ID. Super excited for this, and so how can you win the giveaway? You can share your experience, the whole learning experience on social media. Majorly Twitter, use the tag 30 days of Google Cloud challenge. You 30 days of Google Cloud and cloudy days with DSC Bvp. And tag DSC underscore Bvp. Do not tag any other like profile. Just to be sure, tag only DSC underscore Bvp. So be sure with this. If you have a Flex ID, like Flex profile, it is @meets Flex. Do not forget to tag him. We have Google Cloud India and Google Dsc India. So do tag them as well, and follow us for more updates. We will be having more interesting sessions in the future as well. And obviously, the most interesting tweet at the end of the day will win the giveaway. So do tweet and do get the chance to win these giveaways. Like it is worth it. So thank you so much everyone for being here, and I think that was it from my side. That was awesome. You guys were awesome in the chat section as well, and I think that was awesome. Everything is clear. I hope everything is clear now. And if there is any doubt you have regarding any of the presentation or any of this thing, we will soon update our description box as well. And you can reach out to us on bvp.dsc @gmail.com. We are available there. You can reach out to us from Facebook, Instagram, Twitter, etc. We also have our official page on official.dscbvp.dev. You can go there and have a look up on that page as well. You can join us there. That was all from my side. Thank you so much for joining in, guys. That was awesome. The whole session went so well, and I thank you all for taking your time out for this whole session. You were amazing, and the questions were amazing in the chat section as well. Thank you so much.